that I'm doing. And while most of you guys are probably wondering, why is no one not on YouTube looking for a video that's kind of cool? I'm going to explain that right here. Today we're going to be looking at time crystals, which I believe is a fifth form of matter. As you guys might know, this is a science channel, but what you might not know is I'm not just going to be doing reacting videos and stuff and telling you how it works. I'm also going to be showing you the latest news, how things work, everything like that. So I'm going to give you a brief thing of time crystals, and then I'll get more in detail. So if you just want a brief explanation on them, watch this first part, or listen, or whatever. So time crystals, as I come to know at the moment, is a condensed matter that basically it's always in like repetitive motion, which means it's always moving. So let's say let's say you shocked the time crystal with like a little electricity. Or here, let's start here. Let's say you shocked some diamond or ruby or whatever with a little bit of electricity. What would happen is it would go through, or it would just stop. Probably would just stop and it wouldn't even go in. With a time crystal, maybe I shouldn't use electricity, but let's say you put energy into it, like electricity or magnetism or something like that, which we'll go in a video all about that later. But imagine you do that. What will happen is it will stop. It will never lose that energy. Or maybe it just loses it in very, very, very small amounts. So here, if I were to look up the definition of... Here, we'll look up the second law of thermodynamics. And while this may seem very, very advanced, it's not. It's really simple. I mean, I'm a 13-year-old boy and I can understand it. So what this basically states... here, we'll make it easy for people. Find an easy picture that... I mean, this might work, but that seems pretty hard for... Anyway, so basically, entropy, which is a natural process, it states that one equilibrium state and ends in another will go to the direction that causes the entropy of the system, plus the environment to increase... But what basically that means is the heat from the hot stuff, or the energy, if you transfer it into something cold or something without a lot of energy, it should equal out. But that doesn't work for time crystals. See, what happens with time crystals is, well, they don't really know. But here's a time crystal right here. It looks just like glass or a diamond or another crystal or whatever. But what's different about this is if you put heat or energy into this when it was cold or didn't have a lot of energy, instead of equilibrium, an equilibrium between the two states, this would take all of it. Which means this little crystal, it would completely annihilate the laws of the second law of thermodynamics. It also gets rid of the... I forget what it's called. Anyway. So we'll look at a quick summary of it. A time crystal is an object whose parts move in regular, repeating cycles, sustaining the constant charge without burning any energy, which is what I said. The time crystal is a new category of phases of matter, which, if you guys know what a phase of matter is, it's solid, liquid, gas, and then technically plasma would also be on that. And I guess there's some subcategories like phases of matter or all 7 or something. I forget how many there are. There are a ton. But here they are, I believe. This might be them. No, I don't know if that's it. Anyway, what they are is solids, liquid, gases, plasma, quark, gluon. So basically, ionized plasma is where particles that are either negatively charged or positively charged kind of are heated up so that they basically are like a gas, except they're solid. It's very weird. Quark gluon plasma is only in neutron stars, which are really hot stars that are almost as dense or uh, or as strong as black holes, or their gravity is that strong. Bose-Einstein condensate. Not even I know what that is. Like, I'm pretty decently smart, but not even I know all this stuff. So, this is a condensed matter physics. It is typically formed when a gas of bosons, I believe, are antimatter. Or is that leptons? I always forget. It's very hard. At low density and is cooled. So this is a very, very, very cold thing. So plasma is super, super hot. Bose condensate is very, very cold. So is from an... You know what? I'm not even going to explain it. There are a ton of them. It probably doesn't even matter. Quantum Hall. Like, none of this matters. My point is, technically, a time crystal breaks physics. And I think it's the law of energy conservation. Of energy conservation. It's the amount of energy is neither created nor destroyed. See, for example, when you roll a toward car down a ramp and it hits a wall, the energy is transferred from kinetic energy to... But I can't talk, okay? But what happens with that is kinetic energy is the amount of force of gravity and how much it's moving. Potential energy is the amount that it could move based on its potential and its point and its energy and mass and all that stuff. But what this states is basically what this is if you guys know what a pendulum is, it's like inside one of those old clocks. It's like what goes back and forth. It's what the second is based on. But if you were to where was I going with this? That thing, whether or not you believe it, it loses energy and creates potential energy when it gets to the bottom. Like, at the top, when it's about to come down, it has a lot of potential energy. About halfway through, it has a lot of kinetic. Or a quarter way through, it has a lot of kinetic energy. Middle, it has a good amount of kinetic energy. But when it gets to the other end, it has a ton of potential. But it lost a little of its stuff by using kinetic energy and forming it into the potential energy. So what that means is time crystals don't do that. Instead of having it lose energy, it doesn't. It just stays that way. And that's the interesting thing about it. So tune in next video, I guess. Hope you guys liked this. Remember to like and subscribe. And yeah. Hope you guys stay curious.